And now to learn about some static electricity. All right, so once again, the electrons are on the outer edges of atoms. They can be moved, right? When an atom or a substance gains electrons, that substance or atom develops a negative charge. When they lose electrons, they develop a positive charge. And the world is still filled with electrical charges everywhere. Now, static electricity. This is the buildup or collection of an electric charge on the surface of an object. So, speaking of electricity, it is either the flow or the collection of electric charges. So here we have that collection, that buildup of electric charges on the surface of an object. There is no flow. Static electricity, remember the word static means still. So if something is static, it is still. So there's not a flow of electrons. The charge just builds up. It is static electricity. Okay, because it's not moving, it is a potential energy. It's stored. It's building up. Okay, so static charge and static discharge. Okay, so when you charge something, you are gaining that charge. And when you discharge something, you are losing the charge. So you're either gaining or you're losing that static charge. Okay, and this can happen through three possible ways. Friction, when things rub together. Conduction, which is just through direct contact, not the motion, but the direct contact. And induction, right? When you transfer that charge through that electrical field we talked about previously, not direct contact. Some of these are similar to heat transfer, right? Conduction and induction are definitely methods of heat transfer as well. All right, so friction, when you kind of wipe electrons from one object and transfer them to another. So if you slide something past something else, you create friction. And friction, you're wiping, transferring those electrical charges through that motion of things in contact. Friction only happens when, or it's that friction between objects that are moving. That sliding friction is what is causing us to transfer this charge. When you charge something by conduction, right, electrons are transferred from one another by direct contact. Things are in direct contact with each other, and that is how you charge or discharge. Okay, here we go, charging by conduction. You got a charge object here, you have a neutral object that is not charged. You can see this is charged. You have all these positives here. This is neutral because the positives and negatives equal out. Okay, here, even though they're near each other, we still don't have a charge transfer. Okay, because this object is still neutral. And then, when they come into that contact, you get the transfer of the charge, and now both objects are charged. So you have your green object, which was neutral, has been charged through the direct contact. Now, when you charge by induction, well, that happens once again through that electric field. There is no direct contact. And these are some examples of those fancy chargers that can charge objects without direct contact. You don't have to plug them in. They're charging through an electrical field. They're transferring that charge through the electrical field, but no direct contact. And here is an example, right? Neutral, okay, but what's very important here is it's neutral, but it's polarized. Okay, so if this is a positively charged object, you see these negative charges are kind of attracted to that, right? That's the law of charges. Then we get down here, okay, and this excess charge can somehow escape through a connection to the earth, right? And then there you go. You have charged this other object through induction. Now you'll obviously notice the difference. Previously, we ended up with two positively charged objects. But in this case, because of the polarization and then the loss of the excess charge, you don't lose this charge because it's attracted to this other object, its charge. You lose the excess charge, and then now we have a negatively charged object and a positively charged object. Whereas previously with conduction, you had two positively charged objects. And this would work vice versa as well. If this had started off negative, then we would have ended up with this being positive. So discharge, the loss of static electricity, right? Lightning is a form of electric discharge. So when you lose that charge, that's called discharge, right? And here we have your methodology for lightning. Okay, in clouds, you have your charges that build up on the edges of clouds, and through the electrical field, we can transfer that charge from one cloud to another. We call that cloud to cloud lightning, and as well from cloud to the ground. So lightning charges build up in clouds, and then they get close to the opposing charge and they're attracted to each other, and there you get that discharge. And then the same thing, charges build up in clouds, you get close to the ground, either a area of positive or negative charge, whatever is opposite, and then you get that discharge to the ground. So that basically it's that you're transferring that charge, you're losing that charge from the cloud to the ground, or from the cloud to an area in another cloud with the opposite charge. It's a very good illustration for the discharge we know as lightning. Okay, so conservation of charge. This is similar to every other law of conservation of anything we've talked about. You don't create or destroy a charge, you just transfer those electrons, thereby transferring the charge. So we're not creating or destroying electrons, right? Because we can't do that. We don't want to do that. We are merely transferring electrons from place to place, and with that transfer, we are transferring electrical charges as well. And that is a great introduction to static electricity. Remember, static is the word that means still. Therefore, we're talking about that collection of charges. All right.